Hi all. First, for final review, I would like to begin talking about the enzyme kinetics here. So there's a few points that I would like to highlight from the lecture material and in addition to the review material that we have posted. So first for enzyme kinetics. So when you're talking about enzyme kinetics, there are a bunch of terms that you should understand. So the most important one is that the value of Vmax and Km. So the value of Vmax and Km would be constant within the same enzyme. So if you have enzyme A and you run the reaction using different concentration of substrate, or using different amount of enzyme, the Km and Vmax in every reaction would stay the same because we're using enzyme A, correct? But for the velocity, the initial velocity or V naught or V0 would different depends on the concentration of the substrate. So the first graph that we use to study the enzyme kinetic is the graph when you have the amount of product over time here. And you can see that the amount of product can be in the unit of mole, nanomole, micromole. It doesn't matter as long as the amount of product over time. So times can be seconds, minute, or whatever. So you would have the linear line in this graph. And one thing to keep in mind that if you have this type of graph between product and time, the slope of this graph would tell you the V0 or initial velocity here. So you can calculate the slope of this graph and you get velocity of the reaction. And another point is that, so if you increase the amount of the enzyme in the assay, it would faster the reaction. For example, if you increase like 2 times of the enzyme amount, the slope would also be 2 times of the initial slope, something like this. So if you calculate the slope for the new graph, it would be 2x slope faster than the initial one. Okay. That is the important point from this graph. So the next graph that we are going to talk is the graph when you have V over the concentration of the substrate. So for velocity and concentration of substrate, you will get a hyperbola graph. And this hyperbola graph would give you the, would reach the maximum velocity. So this would be Vmax at this graph. So this graph would tell you the value of Vmax, as you can see from this graph. And also there's a point where you have half Vmax. So at this point, the concentration of substrate that give you half Vmax, we call it Km, right? So Km is telling you the ability of how well the enzyme can bind to the substrate. So if it have higher affinities, it would tightly bind to the substrate. And in other words, it would mean low dissociation between enzyme and substrate complex, correct? So if you have low Km, it means that you have high affinity binding with the substrate. Or here we have low dissociation of enzyme substrate complex. And what else can we obtain from this graph is that when you're comparing the value of either Km and the concentration of substrate. So there's one point when we see that if the concentration of substrate is reaching one point, the velocity would not increase after this. This is because we say that at this point, the substrate is in excess. So no matter how much you would increase the concentration of substrate, the velocity would not change. Correct? So at this point, we can conclude that, well, at this point, the concentration of substrate like higher than Km many times, and I think we cut off at like 100 times. So if you have the concentration of substrate more than the Km value more than 100 times, the velocity at that point would equal Vmax. So this point of velocity would equal Vmax. So that is just to keep in mind that, well, the concentration of substrate equal to Km, you have the velocity equal half Vmax, but if the concentration of substrate more than Km 100 times, that velocity would equal to Vmax. Okay, so from the graphs of velocity and the concentration of substrate can also be changed, can also be modified into the Lineweaver plot. So basically it tells you the same exact information, but we just modify it in order to fit it into the linear relation. So in Lineweaver plot here, you would have y-axis as V 1 over V, and the x-axis is 1 over concentration of the substrate. And there's 2 points that you need to pay attention is the y-intercept and the x-intercept. Y-intercept would give you the value of 1 over Vmax, 1 over Vmax, okay? Not just Vmax, but 1 over Vmax. And the x-axis would give you the value of minus 1 over Km. And so to interpret the Lineweaver plot, when you have the graph that look like this, you should be able to calculate the Vmax and Km from this graph. And please refer back to the question number 10 from the book in the homework problems. Yeah. I already posted the video for the solutions there. So, okay. So that is all different graph types to study enzyme kinetics. I should mention one thing earlier about the first graph over here. In the lecture, we also talking the enzyme assay when you measure the absorbance of one of your product. So this graph can also, the y-axis of this graph can also resemble as the absorbance that changes over time. So absorbance would also mean the amount of product that you are being formed, correct? So yeah, it's chemical C absorbance here. And so to the calculation for enzymes, we focus on only one equation here, which is the Michaelis-Menten equations. So you have V0 equal V max times by the concentration of the substrate divided by Km plus the concentration of the substrate here. So, you can learn how to apply this equation from the homework problems. And so most questions will either ask you to calculate the new velocity or the Vmax or the Km. So it depends on the information given in the question. So if you are given like different bunch of V0, for example, given like different value of V0 and at the certain concentration of substrate. For example, like this. And the questions might ask you to calculate the Vmax. So to use this information to calculate the Vmax, you can either use one of these data points. For example, you can use the pairs of x1 and y1 and then plug in to the Michaelis-Menten equations. So typically the question will give you either the value of Vmax or Km and then ask you to calculate the other value, for example, like that. And so you can find example from like the questions 2 from homework 3 or the question from the book. So the last part of the kinetics is the turnover number of the enzyme. So to calculate the turnover number, in the lecture we refer it as K2, and we calculate it under Vmax condition. So the equation that we use is that the turnover number would equal Vmax divided by the total amount of the enzyme. So Vmax is usually mole per second or mole per minute, and the total of enzyme should be in mole unit. So what does turnover number tell you? So basically, it would refer to the how many times your enzymes got to use to be able to produce the product and reaching that Vmax conditions. So typically in most situations, you might have only very small amount of enzyme, but the substrate is quite large. And in order to reach to produce the product at the rate of Vmax, your enzyme need to work multiple times. So that is what turnover number tell you here. It's just how frequent how frequently your enzyme got to use in order to make the product at the rate of Vmax. So that is the equation here to use. Vmax divided by total amount of enzyme. And please pay attention to the unit, because if you use the wrong unit, you would plug in wrong value and give you a wrong answer. The last part is the IU. So international unit is the unit that we used to talk about the ability. I mean, it reflects the ability of the enzyme that convert your substrate into the product in the unit of micromole per minute. So it's basically IU tell you the amount of substrate that converting into the product in the unit of micromole per minute. So this is very important here of the IU concept. It needs to be micromole per minute. So if the value give you nanomole or mole in 30 seconds, you need to change it into micromole per minute. And please refer to the homework question number 1C that we're talking about 20 IU, right? Yeah. So IU would equal micromole per minute. So for example, if your enzyme turn the substrate into the product at 5 micromole in 30 seconds. So to find the IU, you have to times 5 micromole by 2, because it's this 5 micromole is just in 30 seconds. So you need to find the amount